You've seen them everywhere, right? These incredible, mind-blowing images that AI creates from just a few words. It honestly feels like magic. But what if I told you it's not magic, but a brilliant step-by-step process that's even more fascinating? Well, let's pull back the curtain and see exactly how it's done. Everything starts with data, a truly staggering amount of it. Some of these AI models are trained on datasets with up to 400 million image and text pairs scraped from all over the web. I mean, that's how the AI learns the most basic connection, you know? The link between the word cat and what a cat actually looks like. Okay, but learning what a cat is one thing. How in the world does a machine take a brand new, kind of crazy idea, like an astronaut riding a horse, and build a detailed photorealistic image from nothing, from just random noise? And that's the real mystery we're going to solve today. So, the first big hurdle is bridging this gap between our language, words, and the raw data of an image, which is just pixels. And believe me, this presents a massive computational headache. Just think about it for a second. A single high-res photo has millions of individual pixel values. For a computer to try and generate an image by arranging every single one of those dots directly, it would be unbelievably slow. It's like trying to paint a masterpiece one single atom at a time. It's just not practical. There had to be a smarter way to do it. And here is that big genius idea. Instead of getting bogged down in the messy, chaotic world of pixels, the AI works in a much smaller, compressed space of pure concepts, of ideas. It doesn't think about millions of red, green, and blue values. It thinks about concepts like horseness and astronautness. This smarter, much more efficient workspace has a name. It's called latent space. You can think of it as the AI's private studio where the real creation happens, far away from all the noise and complexity of individual pixels. So, what is latent space, really? It's basically a compressed map of an image's meaning. It holds all the essential info: what objects are in the image, where they are, the style, while throwing away all the redundant, tiny details. It's the difference between a detailed blueprint of a house and a 4K photograph of that same house. And this whole thing is managed by a pipeline called a latent diffusion model. Here's how it works. First, an encoder, called a VAE, squishes a real image down into that tiny latent idea. Then the main AI model gets to work, doing its creative magic on that super efficient blueprint. And finally, a VAE decoder takes that finished idea and blows it back up into the full-size detailed image you see. And this chart really shows you the payoff. Just look at that efficiency gain. By working in this compressed latent space, the amount of computer power needed can be slashed by a factor of 48, sometimes even up to 256. This is the innovation that truly made high-res AI image generation practical for all of us. Okay, so we've got our efficient canvas, the latent space. But how does the AI actually, create anything on it? The technique is called diffusion, and the best way to get it is to think like a sculptor. See, the AI doesn't start with a blank slate. It starts with a block of pure random chaos. It literally looks like TV static, and its job is to methodically chip away at that chaos, piece by piece, step by step, until a clear, coherent image emerges from inside it. So how does it learn to be a master sculptor? Well, in this beautiful kind of backwards process, the AI first has to learn the art of destruction. It's trained by taking perfect, beautiful images and systematically ruining them. This part is called the forward diffusion process. So, during training, it all begins with a perfectly clean, normal image from its dataset, just like this one right here. Then, in a very controlled, step-by-step process, the model adds a tiny bit of random noise, and then a little more, and a little more. This can happen over and over again, sometimes for 1,000 steps. And eventually, all the original information is just gone. It's been completely wiped out, and the image is reduced to nothing but that random staticky noise. The AI has now watched the entire journey from perfect order to complete chaos. Now here's the clever part. The AI's real training is to learn how to reverse that entire journey. At any given step, it's taught to look at a noisy image and predict the total amount of noise that was added from the very beginning. Not just the little bit from the last step, but the whole mess. This is the secret to its creative power. And this is why the method works so well. Trying to generate a whole complex image in one shot is, well, it's basically impossible. But predicting a tiny bit of noise at each step, That's a much, much simpler task. As the original paper puts it, it breaks a complex global problem into many simple local perturbations. It turns one impossible problem into 1,000 easy ones. Right, so the AI knows how to sculpt an image out of a block of noise, but how does it know what to sculpt? How does it actually listen to our text prompts? The answer is a brilliant model called CLIP. The best way to think of CLIP is as a universal translator between words and pictures. It's been trained to create this shared mathematical space where the text, a photo of a dog, lives right next to an actual image of a dog. It literally builds a bridge connecting language and vision. So, when you type in your prompt, CLIP turns it into a mathematical instruction that acts as a conditioning signal. It's like a blueprint or even a magnetic force. At every single step of that denoising process, it's pulling and guiding the creation toward the concepts in your prompt, making sure the final sculpture matches exactly what you asked for. Okay, last piece of the puzzle. Let's look under the hood at the engine that's actually driving this whole process, because the architecture of these models has been evolving really, really fast. Older models used something called a unit, which is fantastic at understanding local details, like the texture of fur or the shimmer on water. But the newest models, like Stable Diffusion 3, has switched to what's called a diffusion transformer, or DIT. Transformers are absolute masters of seeing the big picture. They get the global relationships and the overall composition. And that's a huge reason why recent models are so much better at creating complex scenes that actually make sense. So let's just do a quick recap of the whole amazing journey. We start with a simple text prompt. The AI then enters that compressed idea space called latent space. It starts with a canvas of pure random noise. And then, step by step, it beautifully chips away at that noise, all while being guided by our prompt. And finally, a decoder translates that finished idea back into the stunning, full-resolution image we get to see. And there you have it, from pure random chaos to structured, incredible art, all by learning how to perfectly reverse a destructive process. It's such an elegant and powerful system, and it really forces us to ask a pretty profound question. If this level of creativity can be learned simply by reversing chaos, what are the real limits of machine imagination?